Alrighty, today we're going to be talking about limiting reagents and percent yield. This is building off of our basic ideas of stoichiometry to solve more complex and advanced problems. But before we do that, I want to recommend a method for taking notes during these videos this year. A template very similar to this that we modeled in class. Date, title of the video at the top. Today is limiting reagents and percent yields. You take your notes throughout the video in some blank space, whether this is on blank binder paper or in a composition notebook, it doesn't matter. But I do want you to, at the end of the video, do two things. Number one, write down any key vocab terms in one section, one box on your notes, because you'll be making flashcards out of them. Our study skills will be able to pull key vocabulary out, identify them, and also generate a question about the content from the video, either as an extension or a review question, but everyone needs to have one question. I'll be looking for that to make sure that you are thinking about the material and reflecting on it afterwards. So to talk about percent yields, we're first going to stick with a non-chemistry example. So let's say you work at a factory that makes cars, and you are the very last person at the end of the assembly line. So what you get is the body of the car, and you get some tires. And it is your job as the last person to the assembly line to put them together to roll the car out so it can go to the dealership and be sold. So to do this, it takes one body, one car body, and I know I only made two, but if you actually make a real car, we all know in 3D you have to have 4 tires in order to make one car. We can represent that as a chemical equation. Okay. So let's say you show up to work, you're at the assembly line, and you see that you have 10 bodies and you have 16 tires waiting for you to put together to make cars. Well, you want to think about how many cars can you actually make? Well, if you have 10 bodies and it takes one body to make one car, it's a Molar Ratio, 1:1, by looking at the coefficients, you can make a maximum of 10 cars. If it takes 4 tires for one car, and you have 16 tires, the maximum number of cars you can make is 4 cars. So in this case, you are going to run out of tires before you run out of bodies. So we would call the tires the limiting reactant. The limiting reactant is the reactant in the chemical reaction that limits the amount of product you can make. Whereas the bodies, you're going to have extra, you're going to have excess. So we call the bodies the excess reactant. The excess reactant is the reactant in a chemical reaction that you will have leftovers of when the reaction is complete. The maximum number of cars you can make, the maximum amount of product you can make with any given amount of reactants, in this case is 4 cars, and that has a specific name. That is called the theoretical yield. With 16 tires and 10 bodies, you can make 4 cars. That's your theoretical yield, the maximum amount of product you can make. That's a non-chemistry example. What does a chemistry example look like? Well, let's say you have a problem that asks you, what is the theoretical yield of H2 if 79.1 grams of zinc reacts with 163.1 grams of HF according to the following equation. Zinc plus 2HF goes to zinc fluoride plus hydrogen gas. So the way you solve this problem is the same way we would do any gram-to-gram problem, except now you have 2 reactants. More specifically, you have the mass of 2 reactants given to you. You have the mass of zinc and you have the mass of hydrofluoric acid. So what we have to do is do basically 2 gram-to-gram problems. But since you should be comfortable with these, this should not be too hard. So the setup, A, this is with the zinc, okay, is 79.1 grams of zinc. We use the molar mass of zinc, which is 65.4 grams of zinc in 1 mole of zinc. Use the mole ratio for coefficient is 1 mole of zinc makes 1 mole of H2, And for 1 mole of H2, last step is molar mass, 2 grams of H2. Cancel out my moles of H2, my moles of zinc, my grams of zinc. If I do the math, multiply across the top, and divide by what's across the bottom, I'll get a final mass of 2.42 grams of H2. 3 sig figs, because I was given 3 sig figs to start. Okay, so that's possible. Let's pretend we used up all of the hydrofluoric acid, HF. Well, we have 163.1 grams of HF. We do the same setup. But now we need to use the molar mass of HF, which is 20 grams. We use the molar ratio of HF to our product. Uh-oh, I can't just assume it's 1 because I have to look at the equation. 2 moles of HF for every 1 mole of H2. And then again, 1 mole of H2, just to emphasize, this is not from the equation. This is for the molar mass step, it's always 1 mole. Gives me 2 grams of H2. I cancel out my units here. I do the math across. I will get a final answer of 8.155 grams of H2. 4 sig figs because I have 4 sig figs back here. So now the problem is, what's my limiting reagent? What is my limiting reactant? Well, your limiting reactant is going to be the reactant that gives you less product. So since I have less product when I use zinc than when I use hydrofluoric acid, we would say that zinc is going to be my limiting reactant. It limited how much product I can make. On the other hand, HF is going to be my excess reactant. I'm going to have leftover HF after this reaction goes because all of the zinc is going to get used up before all the HF gets used up. And then since zinc is my limiting reactant, the 2.42 grams of H2 is going to be my theoretical yield. Now, let's say you did this reaction in class. You mixed some zinc, 79.1 grams of zinc with 163.1 grams of hydrofluoric acid, and you got a product of, let's just pretend, you got a product of 1.68 grams of H2, hydrogen gas. Well, you know that you can get up to 2.42. So we want to think about how good were you? What was your percent yield? So to figure that out, your percent yield is going to be equal to your actual yield, or experimental yield, another word for it, divided by your theoretical yield, times 100. So in this case, our percent yield would be what we actually got. Again, I just made up this number, 1.68 grams of H2, divided by our theoretical yield, which was 2.42 grams of H2, times 100. So if I do that math out, 1.68 divided by 2.42 times 100 would give me a percent yield of 4%. That would be my percent yield in this problem. Simple enough. Now, one key point I want to point out. You cannot figure out what the limiting reactant is by simply looking at the masses of the reactants you start with. It would not be correct to say, oh, zinc is going to be my limiting reactant because I have less of it. I only have 79.1 grams compared to 163.1 grams of hydrofluoric acid. In this case, it just happened to be that zinc was the limiting reactant. But that is not the case always. You will always have to figure out the theoretical yield for both, or as we'll learn later, a little trick using the number of moles of each that you will have.